Welcome to this video on the Kelvin scale. Temperature can be measured in two different scales, Kelvin or degrees Celsius. In everyday life, we tend to say the temperature in degrees Celsius. However, in thermodynamics, we can use the thermodynamic or Kelvin scale, which is commonly used in science. The important definitions are 0 degrees C is equal to 273 Kelvin, and therefore 0 Kelvin is equal to minus 273 degrees C. An increase in both scales is the same. Therefore, the difference in temperature between two numbers will be the same on both scales. For example, the difference between 27 degrees C and minus 173 degrees C is 200. Now, the Kelvin equivalent, the difference between 300 Kelvin and 100 Kelvin, is also 200. To convert from Kelvin to degrees Celsius, you need to take away 273. To convert from degrees Celsius to Kelvin, you need to add 273. This conversion is important for gas laws such as the change in pressure with temperature at constant volume. The pressure is proportional to the temperature when the temperature is in kelvins. Make sure you memorize these equations. They will not be given on your formula sheet. 0 Kelvin is a special value called absolute zero. This is the lowest temperature possible. At this temperature, particles have zero kinetic energy and therefore zero pressure. Their motion has completely stopped. For example, particles in water at 0 Kelvin are completely still. This is in comparison to ice, which is formed at 0 degrees C, or 273 Kelvin, where the particles, although tightly packed, are still vibrating. Water eventually turns to water vapour at 100 degrees C or 373 Kelvin, where the particles have a high velocity. These temperatures are easy to remember in Celsius, but just add 273 to convert into Kelvin. Nothing can have a temperature below absolute zero. This means the temperature in Kelvin will always be positive. You cannot, for example, have minus 2 Kelvin. Therefore, always check whether your answer in kelvins is positive. If it is a negative value, you must correct your error in your calculation. Let's try a few examples. Part A asks us to convert minus 44 degrees C to Kelvin, and Part B asks us to convert 372 Kelvin to degrees C. For A, consider the equation for converting from degrees C to Kelvin. We must add 273 to minus 44. Substituting the value into the correct equation gives 1 mark. This is 229 Kelvin, the second mark. For B, consider the equation for converting from Kelvin to degrees C. This time, we must take away 273 from 372 for the third mark. This gives us 98 degrees C for the final mark. Let's check whether our answers make sense. The value in Kelvin needs to be positive, so A looks okay. Let's say for part A you accidentally take away 273 from minus 44. This gives minus 317 Kelvin, which is far below absolute zero, so this is not possible. The value in kelvins will always be more than the equivalent value in degrees C, and vice versa, so B also makes logical sense. Always show your full working for all calculations in your exam. This is so you will be awarded method marks. Let's try an example with gas laws. From the definition of absolute zero, this is where there is zero pressure. This is either at 0 Kelvin or minus 273 degrees C. In A, zero pressure is at minus 273 Kelvin and not degrees C, so this is incorrect. In B, the pressure is zero at 0 degrees C. This is not correct, as ice will still have pressure as the molecules are vibrating. This should be 0 Kelvin. In C, the pressure is zero at 273 Kelvin. This is incorrect, as it should be 0 Kelvin. And finally, D is our correct answer. The pressure is zero at minus 273 degrees C. Make sure to always read the units carefully on all graphs. In summary, temperature is also measured on the Kelvin scale, which is commonly used in thermodynamics. To convert between a temperature in Kelvin and degrees C, the temperature in degrees Celsius is a temperature in Kelvin minus 273, and the temperature in Kelvin is a temperature in degrees Celsius plus 273. A change in temperature on both scales is the same. Absolute zero is defined as the lowest possible temperature. For an object at absolute zero, its particles are completely still with zero kinetic energy and zero pressure. This is at 0 Kelvin or minus 273 degrees Celsius. Don't forget to check out all our other fantastic revision resources here at Save My Exams.